So here we are on page 2 of the addendum for integration. So we're going to do this problem here at the top, problem 9. We're going to find the derivative of e to the negative x sine x, and afterwards we're going to find a related integral. So the derivative of e to the negative x sine x, that's a product. So we're going to do e to the negative x times the derivative sine, which is cosine. We're going to add that to the derivative of e to the negative x, which would be negative e to the negative x, and then we just write the other expression next to it without taking the derivative, because it's, remember, the product rule is u v dash plus u dash v, right? So now we have this expression, and if we rewrite this expression with e to the x in the denominator, because e to the negative x is the same thing as 1 over e to the x, right? We would have cosine x minus sine x divided by e to the x, right? And then do you see what happened here? We actually have the exact expression there. So the integral of cosine x minus sine x divided by e to the x, of course, is going to be the original expression here that we took the derivative of. So the answer is going to be e to the negative x sine x plus c. Number 11. Find the derivative of secant x and hence find the integral of secant tangent x. And so on the previous page we saw that the derivative of secant is secant tangent, okay? And if you want to do it the long way without using the formula sheet, you could say, okay, the derivative, or secant x is actually equal to 1 over cosine, which is equal to cosine of x to the negative 1, and then use the power rule and the chain rule, and then you would end up with this expression here as the derivative. So the derivative of secant x is equal to secant x tangent x. And so if I know that this is the derivative, then if I want to take the integral of that same expression, I'm going to get the original expression we took the derivative of, which is secant x plus c. Okay, wow, these are pretty easy so far, aren't they? Okay, number 13. Find the derivative of arc cosine x and the derivative of arc sine x. Remember that the derivative of arc cosine x and arc sine x look almost exactly the same. Arc sine x, if I remember right, is like 1 over the square root of 1 minus x squared. And the derivative of arc cosine x is similar, except it's just negative 1 on the top, and then on the bottom it's going to be 1 minus x squared. So they're almost the same. They're very similar, right? Now, hence, find two expressions for the integral of 1 over 1 minus x squared. Well, one of them is really easy. If I wanted to find the integral of this expression, it would just be arc sine, right? So one of the possible answers is arc sine. Now the other possibility is that, look, arc cosine almost looks like it, except for it's negative, right? So I could say that the integral of 1 over 1 minus x squared is equal to negative arc cosine, right? Because if I took the derivative of negative arc cosine, I would get negative 1 over 1 square root of 1 minus x squared, which is this, right? So this is also a possible answer. So basically that's the explanation. The negative here is basically undoing the negative here, right? Okay. Next one. Number 2. Find f of x given that the derivative function is square root of x minus 2 secant squared x, and f of pi is equal to 0. So they give us some initial conditions here to figure out what c is going to be, but first we just need to figure out the integral without the c, right? So if they're saying that the derivative of this, and they're saying what is the function, basically what they're saying is they want the integral of this derivative function. So the integral of that, let's rewrite the square root of x is x to the 1/2, and then we can use the power rule on it, right? And then we need to take the integral of secant squared. I believe that the integral of secant squared is tangent because the derivative of tangent is secant squared. Let's go up and make sure that that's what we saw earlier, right? Yeah, the derivative of tangent is secant squared. So, okay. So this part, negative 2 secant squared, the integral is going to be negative 2 tangent of x, right? The first term, x to the 1/2, when we take the integral of that, it's going to be x to the 3/2 divided by 3/2. Okay, and the 3/2 can be inverted and multiplied just like we learned in elementary school. Okay, fraction rule. And plus c, of course. Okay, so that is our integral. And then we can put in our two values, which are, we're going to put pi in for x. So we'll put pi here, and we'll put pi here. And then we'll set it equal to 0, and we'll see what c is equal to in that case. So, let's see. I'm going to make this a little bit smaller because I was not generous with the space on this problem set, right? Okay, so if I plug those in, I'm going to get 2/3 pi to the 3/2 minus 2 times tangent of pi plus c equals 0. Tangent of pi is equal to 0, right? Because sine of pi is 0, cosine of pi is -1, 0 divided by -1 is 0. So this is actually 0. And that means that basically we have 2/3 pi to the 3/2 plus c equals 0. Equals 0. And then so the c value is equal to negative 2/3 pi to the 3/2. So that's our c value. Okay, and so if we wanted to, does it say to, yeah, it says to find f of x. So let's write f of x formally in all its glory here. So we'll write f of x equals, this is how you would write the answer, 2/3 x to the 3/2 minus 2 tangent of x plus c. It will be minus 2/3 pi to the 3/2. Okay? And that would be how you would write the answer. Okay, next section, 21f, integrating f of ax plus b. So we did this section. Now, we're just going to do the extra HL integrals along with this. So remember, if you have a linear expression inside, instead of just a plain old x, you can undo the chain rule of this linear expression by dividing by the a value. Okay? So, basically we know that the integral of secant squared is tangent, right? So basically we just do kind of like a chain rule. So we put the same function inside as we do here, right? And then we test it. We could test it by taking the derivative of 1 over a tangent ax plus b. That would be secant squared of the same thing inside. And then we'll take the chain rule of this. We'll get a. And then you're like, oh, wait a second. I have 1 over a here. The 1 over a cancels with the a. So I end up with just secant squared ax plus b. And that's what I wanted. So it worked. We checked it and it worked. All right, integrate with respect to x this expression here. Okay, so this is very similar. Basically, what the rule says is I should take the tangent of the same expression, and I should divide it by a. And a here is -2, so I'm going to divide by -2. I can't forget that there was a coefficient of 4 here. So now that I did that multiplication, I can, let me just make myself some more space here. I'll put it here. So that's my initial guessed answer. And then I'm just going to simplify it because I could divide the 4 by I could divide 4 by -2, and then I end up with this expression here. And of course I should put a plus c, right? Okay. So here is my answer. If I wanted to test it out, I could say, okay, the derivative of tangent blah 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 is secant squared blah blah blah, and then I'm going to do the chain rule on it. So the -2 is going to pop out. The -2 multiplies times the -2, and I get 4, and that's what I wanted. So the check that I did worked. Okay. Number 6, use the identity cosine squared equals 1/2 plus 1/2 cosine 2 theta to show that blah 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 blah. Okay. So the first part of this is not an integral problem. It's just a trig identity problem. So can we take this and figure out an expression for cosine to the fourth? Well, the most obvious thing to do is to square both sides, right? If I squared both sides, I would have cosine to the fourth theta on the left, and on the right side, I would have 1/2 plus 1/2 cosine 2 theta squared. And if I have that, then I could do FOIL, right? So I would have 1/4, which would be the first term squared. The last term squared would be 1/4 cosine squared 2 theta. And the two middle terms would be 1/4 cosine 2 theta and 1/4 cosine 2 theta. 2 theta and 2 theta. Let's see. And so we could combine these two like terms, right? So we'll have 1/4 plus 1/2, because 1/4 plus 1/4 is 1/2, cosine 2 theta. Oops, and this is also a plus, right? Plus 1/4 cosine squared 2 theta. Oh, but look, cosine squared 2 theta, I know an identity for cosine squared 2 theta. I could put 1/4, and I'm going to put cosine squared 2 theta, and so I'm going to put 1/2 plus 1/2 cosine 2 theta, which is going to end up being 4 theta, right? So I think I wrote this way too big, because not too much space left. Okay. So let's simplify this. So 1/2 plus 1/2 is 1/4. Oh, I can't do that because look, the 1/2 is multiplied times that. So this is actually equal to 1. If I have 1/4 times 1/2, it would be 1/8, right? 1/8 cosine 4 theta. And then here I got 1/4 times 1/2. It would be 1/8 here too. And then I have this 1/8 plus this 1/4. 1/8 plus 1/4, that's 2/8 plus 1/8, which is 3/8, common denominator, right? And then the second term is just going to stay the same because I have no other cosine 2 thetas. And the last term is now going to be this part here, which is going to be plus 1/8 cosine 4 theta. And does that match? 3/8, yes. 1/2 cosine 2x, yes. And 1/8 cosine 4x, yes. Now I forgot that there are x's here and not theta, so I can replace all those, okay? So remember that basically what we did here was that cosine to the fourth x is equal to this expression, except for I'm going to put 2x and 4x instead. Okay, so I got that. Then what they want to know is, okay, what's the integral of cosine to the fourth x? And that's actually a pretty hard problem because you try to do this. I mean, if you want to find the integral of cosine to the fourth, you think, oh, that's power rule. And then you're like, okay, so that means it would be cosine to the fifth divided by 5. And then like, you're like, okay, let's test that. So if I test this, I'm going to take the derivative. It'll be 5 cosine x divided by 5. And then the cosine, I'm going to do chain rule. So it'll be negative sine x left over here. And oh, there's no negative sine x here. So it didn't work, right? The problem is that the chain rule is going to end up kind of ruining it. So one trick you can do to avoid that problem is if you convert your cosine with this high degree of power and you use this identity here. Look at this identity. It's pretty cool. It takes the squared cosine and it reduces it to a regular cosine with just a bigger angle. And like it's pretty easy to take the integral of a single cosine without a square on it because there's no chain rule, or there's no significant chain rule. The chain rule is just going to be a coefficient, which is easy to cancel out. So I'm going to rewrite cosine to the fourth, which is difficult to take the integral of. I'm going to rewrite it as this expression here. So I'm just going to put the integral of blah, 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 and what's blah, blah, blah? It's this expression there. Okay? So now it's really easy to take the integral of, because I just take the integral of 3/8, I take the integral of cosine 2x, and I take the integral of cosine 4x. Those all can be done by just looking at the expression inside here and doing the reverse chain rule. So I'll show you how it's done. So the integral of 3/8 is going to be 3/8x, right? The integral of 1/2 cosine 2x is going to be sine 2x let's see, divided by 2. So I already have a coefficient of 1/2, so it'll be 1/4 instead. Let me check to make sure that's right. If I'm going to take the derivative of this, it would be 1/4 cosine 2x, and then the chain rule would put a 2 on the outside. It would give me 1. Yeah, that worked, okay? And then, so that would be, the derivative of 1/4 sine 2x is going to be that term right there, right? And the integral of 1/8 cosine 4x is going to be sine 4x, and then I'm going to divide by 4. So this would be 32. Did that work? Let's try it out. So we're going to take the derivative of this. 1 over 32 cosine 4x, and the chain rule means I'm going to put a 4 outside. This is going to reduce to 1/8. Yeah, that's exactly what's there, right? So that worked too. Okay, so there's my answer right there. And of course I need to put plus c. Now that I remembered about plus c, let's go back and look, see if I put plus c on everything else, and I think I did. And that's the end of page 2.